technology has been taken care for the agricultural side. And similarly, the same kind of applications and what all the advantages of lidar and what is the disadvantages of that lidar scanners in the uh, utilizing for the agricultural industry, what we are going to discuss in today's session. And then after this, next thing what I'm going to talk about is what are the remaining applications of these 3D printers of Artec 3D printers, or along with the other some of the possible applications. Okay, and as we said in the earlier stages itself, these scanners are not only meant for one particular application, and this can be utilized in all the multiple industries. So we will look into that and we'll conclude this today's entire presentation. And my request is to please be ready with your questions, and if you need any more clarity on the things, or you want to have some um, more knowledge, or if you want to know anything about that, so please be ready with your questions. And by end of this today's session, before we conclude by 3 o'clock, we'll have some question and answer session. So that time you can chat it in chat box, or we can just ask, you can unmute yourself and you can ask some questions. Okay, so let's begin with the today's presentation. So today we'll mostly talk about lidar section. As I said, as everyone might aware, or who are very new to this, what is lidar based measurement system. So lidar is a light detection and ranging, and this is a far away from controlling systems. So that means there will be a laser scanners which should be mounted on some equipments. Either it might be on a tripod based, or it might be on a airborne device. So what it happens is that it will projects the light patterns, and it will, whatever the reflection is happening, so that will be calculated and it will recreates the entire scenario. Okay, so it is just like a 3D scanners. It's a 3D scanners in one or other way. But what advantages is that here, with the normal 3D scanners, like what we discussed in the last sessions of Artec EVA and other scanners, so those are basically for scanning the engineering level components, right? Maybe it's from a size of some small car key or drone, or what I can say, that the irrigation or sprinkler knob, to your a part level size of some automotive tractor or automotive plough or automotive equipments or AG vehicle equipments or any kind of other smaller components, right? But when it comes to a matter of scanning larger components, okay, might be it's a more than some 10 meters part, assume, like the elevated truck, or any kind of land, um, what I can say, the land leveler, or any kind of equipments, related equipments, you need to do a 3D scanning, and you want to it might be for the design purpose, or it might be for the inspection purpose also. In that case, these normal 3D scanners will not comes into picture, right? Those handheld 3D scanners. So then it comes to applications of long range scanner, where it will scans more than 10 meters per year, kilometer level. Okay, that means there is no any limitations. Again, here also it all matters with the capturing area, what we call field of view of the scanner. Similarly, as you have seen in the previous sessions, those scanners will comes up with a smaller field of view. So that is the reason they are meant for scanning the smaller components. But as these lidar based scanners have larger capturing area, so we can scan the larger components, and also we can implement the same things or the same equipment for the applications of agriculture also. Let's see what are the applications of that. And again, this is one of the most advanced and accurate technology, okay, compared to all the existed methods. It might be camera based, or it might be a radar based or anything. So a lidar based technology is one of the most accurate models what you can get, what you can 3D mapping, you can get it from the compared to any of the other technology. Okay, and these lidar technologies are mostly used in the applications of creating a BIM, what we call a building information modeling, which is an industrial application and civil application, where they will reconstruct the buildings, and if it's any plants or need to be re-implemented, or if they want to accommodate a locations or the space for some particular machines or any kind of new devices. So in order to utilize that, they will use these lidar based long range scanners. Okay, basically what we call it as a long range scanners. And then today we'll just discuss, and generally these are discussed based on two types of, one is topographic and bathymetric. So topographic lidars are basically using a infrared and laser map to in order to map a land, whereas the bathymetric lidars uses a water penetrating green light to measure the sea floor or river beds as well. And here furthermore there are multiple classifications are there based on that whether that is passes through the clouds in order to analyze the weather report, and also in order to analyze the wind speed. So there are a lot of different things are there, but now just we will restrict to this, and then we'll just move on to the next slide, because we are concentrating much on creating a 3D mapping of the locality, okay, with these long range scanners. So that is the reason we are just restricting to that method, and we'll move on to next slide. So this is one of our scanner, what we call RTEC ray, which is for scanning the longer objects, or the more than 10 meters apart. We'll just show it up. I'll just play a video of this. I'm not sure whether the video is playing with the audio. Better I'll just reshare it once.
Scanner designed.
Hope the audio is
RTEC
audible
Ray
now.
is a 3D scanner designed to scan large and very large objects. For example, airplanes, ships, windmills.
Is it audible, everyone?
Yes, audible.
Yes, sir. Thank you. Okay.
Propellers. RTEC Ray is a 3D scanner designed to scan large and very large objects. For example, airplanes, ships, windmills, propellers, etc. Using this scanner, you can quickly create a 3D model of large production areas or objects. And the high accuracy of the scan allows you to use the data for engineering calculations. RTEC Ray is capable of scanning over long distances. Its working range starts from 2 meters and reaches up to 110 meters, which is more than the height of the Statue of Liberty. The scanner works with sub-millimeter accuracy and gives some of the best results among laser scanners. RTEC Ray works with industry-acclaimed 3D scanning software, RTEC Studio, so the scanner is well integrated with all RTEC products. The best solution is to use different types of RTEC scanners, for example, RTEC Ray plus RTEC EVA, because large objects often have certain zones which are difficult for one scanner alone to capture. But Ray is very different from other RTEC scanners. It is not handheld, but rather a long-distance scanner. The laser beam moves in a vertical plane and scans the space around, managing to create more than 200,000 points every second. The reflections of the laser are caught by a round rotating mirror, while the scanner itself rotates in a horizontal plane, 360 degrees, while the scanner covers 270 degrees vertically. To scan complex scenes from multiple angles, all you need to do is place standard spheres or even 2D targets around the scene for fast and effortless alignment later on. RTEC Ray also records color data to make navigating through your scans that much easier. It is very easy to work with a scanner. One person can control it. The scanner weighs about 5 kilograms and it requires a fixed tripod as well as a computer. Within just a few minutes, RTEC Ray is able to scan a large space, and then the tripod is simply moved over to another spot, and the operation is repeated as many times as necessary, so that all the dead zones are scanned by Ray's laser beam. It is possible to scan not the entire space, but only selected areas, using the selective scanning function. It is interesting to note that you can do this even without a computer. You can control the scanner with an iPhone or an iPad. So the data in this case is written to the SD card. And RTEC Studio will receive it later on by reading the data from the card. Raw data from RTEC Ray is in the form of a dense point cloud. RTEC Studio transforms the point cloud into a polygonal mesh using its well-known versatile tool set. The point cloud can also be exported in formats specifically designed for this kind of data. The polygonal model is stored in other formats, which are usual for 3D models. The post-production process for Artec Ray is the same as for other Artec scanners. Users must take into consideration that the final file can be larger than usual. Artec Ray can capture some truly huge objects.
Okay, that's all about Artec Ray scanner. As you have seen that it is completely capable of scanning larger components, and it's a recently launched product compared to of our other products. And the advantages of Artec Studio is that it is the only scanner in the market which is having this much of high accuracy, what we call 25 arc seconds. Sorry, there is some disturbance at my end. Just a second. Sorry for the disturbance. What actually I was telling, the Artec Ray is the only scanner which can give you that much of high-end accuracy of 25 arc seconds. And similarly, if we talk about in terms of a length, 0.3 mm at a distance of 15 meters. So that is the level of accuracy what we will get with the Artec Ray. And this is a most versatile tool. And as we know that when we doing the long range scanning, it might not be possible to, if it is moving on a tripod based, we can't able to move the scanner one place to other, means we can't able to move the scanner in freely as it happens in the through the drones or other applications, right? But advantages of Artec Ray is that when it is scanning with the long range scanner, which all are the minute details which has been left out during that scanning, so that will be captured by the with the other scanners like Artec EVA or Artec Space Spider or any of the other scanner. And as we have one unique software, the same software for all the scanners, what Artec Studio. So the procedure is same. We can import it and we can merge and we can get a completely 100% packed 3D model. So that's what about Artec Ray, and these are some of the output from Artec Ray, how it will looks like, and even we can able to capture the color details also in with the Artec 3D scanner, which is a Artec Ray. And there are, other than this, there are different kinds of scanners in the market. There are other different kind of 3D scanners also there for the lidar based. So and all those scanners works on different principle and different methodology. Like some nowadays they're also started to working in terms of camera based on image processing methods now. But again, putting all together, I have just come up with a total overall solution as a how it can integrate in the agricultural field. Okay, so now let's move on to the next slide. So yeah, this is about Artec Ray tracking range, that is 110 meter in one single shot. That means if you are placing a scanner at one location up to a length of 110 meter, it can able to captures the data. And as you have seen in the video, the scanner will just rotate in horizontally. Am I audible to everyone? Because for me to showing my internet is unstable.
Yes, sir. Yes.
You are audible.
Okay, sir. Thank you. If it's any disturbance happens, please do let me know, sir. Okay.
Yes, sir. Yes.
Okay, thank you. So that is up to 110 meter in one single shot. So when it is rotating in horizontal, okay, so it can able to capture 110 meter in total, and then again in vertically it will also captures 250 degree. Okay, so 360 degree it can rotate horizontally, and vertically it will capture 270 degree, except the base of the scanner. So it's the same way you have to move the scanner from one location to other location if we are expecting to scan the other side of the object, and then based on that we can merge in a software and we can get a model. So I'll tell you what is the advantage, because when we are talking about long range scanning or huge data handling, so the software has to be very much more precise, and it has to be very good enough to handle that much of huge amount of data what it is capturing, right? So that is the one what Artec Studio is meant for. So that is the reason we can easily get a larger components, and the processing like scanning is a one aspect. Within 4 minutes it will complete one single scan. Similarly, after the scanning, what are the steps involved? So again, it's a days together of work, whereas with the softwares, and here that also has a most optimized software for the the same application. Okay, and one more advantage is that the output formats of Artex Studio, what Artex Studio can give you is that it can give you all the formats like PLY, WRL, STL. So these are a kind of a formats which can be readily integrated output formats for the other applications. Okay, not only for reverse engineering, for the other applications like the AR VR applications, or the application like where you want to integrate a entire scenario for your courtroom application or anything, like it might be for the forensic applications or anything, for the clearer analysis based on the different softwares. So that's the only software which can give almost 10 different kinds of output formats for the from the scanning. Okay, so this is about Artex Studio. And telling about a laser, it's a class 1 laser. And one more thing is that the working principle of this scanner is called phase shift method. Okay, when we say phase shift method, there are two methods generally it will be used. One is time of flight and one is a phase shift method. Here it's a phase shift method. That means whatever the distance it is taking to reflect the time. Okay, when it hits the object and it is reflecting, so that will be calculated and distance will be calculated, and sinusoidal wave, based on the sinusoidal wave difference, it will calculate the distance that will reconstruct the scenario. Okay, and one more method is called time of flight. So the time of flight is detected by calculating the distance from which the light of laser going and hitting the object, and when it is reflecting back, so that time will be calculated, and based on that time the scanner will recreate the scenario, right? But compared to phase shift and time of flight, phase shift is the most advanced as well as it is the most accurate method of getting a 3D models from the methodology in the existed current technology. Okay, so this is about it, and I have one more video of some applications to give an overall video how these applications work.
Scanning solution. While most scanners on the market are big, heavy, and difficult to transport, aircraft scanning takes time and coordination. Terrestrial laser scanners on the market are big, heavy, and difficult to transport. Aircraft scanning takes time and coordination. Terrestrial laser scanners take time to set up and process. Mini provides you an aerial mobile scanner from the back of your car. Complete 10 acres in 10 minutes for topographic mapping. Capture 3D feature scans in 20 minutes. Photomapping can only map the tops of vegetation, but lasers poke through to see the ground below. Mini uses the light payload system, which allows you to load and remove just like any camera system. All you have to do is fly your camera mission, then land, load Mini, and fly your reality capture project. It's that easy. Since Mini uses the M200's obstacle avoidance, you can fly with the confidence you will not hit a tree or building. Use the advanced flight automation to plan and execute missions that account and adjust for the ground or obstacles. Not sure of the ground? That's okay. Load digital elevation models from photos, other laser scans, or satellite to ensure you and your drone know the ground truth. Using lasers to map requires your drone to fly differently than a camera. The mapping planning tools also make sure you fly the right way and optimizes your collection every time. Setup is easy with one-button start and Wi-Fi payload connections. No cables or preloading before coming to the field. Fieldwork is also streamlined. Take advantage of high-end positioning systems, eliminating the need for time-wasting calibration flight patterns. Need higher accuracy? Leverage professional survey-grade correction tools to ensure you deliver a project you can certify. The embedded control tools allow you to correct your data beyond just the mobile solution before you create your point cloud. This is a big time saver for your CAD or GIS data analysts. Post-flight processing is simple. 1. Download. 2. Sync. 3. Combine to generate high-definition point clouds for your engineering and mapping projects. Have imagery of your project? Fuse together photos and laser data to create rich three-dimensional color models at a fraction of the time of traditional methods. Finally, data compatibility is key. The Mini Kit allows you to convert between 250 different file types. Mini is perfect for survey-grade topography, cut and fill calculation, rapid volume calculations, feature extraction, GIS vegetation management, city planning, and more. If you need to produce a rapid reality model for your engineering or survey team, Mini may be the solution.
Sir, you are not audible, sir.
Sorry. Yeah, this is the kind of a scanner now that as the technology is evolving, they are come up with the airborne 3D scanners also like this laser based. What they are doing is that just by mounting on the drones and also some other air devices, so you can easily scan the entire land, and then based on that you can get a complete 3D. And now as the technology is evolving, the accuracy level is also getting stabilized, and it might take some more years to get the total details. But this is what it is happening just to calculate different applications and different things, what we're going to discuss in the next slide. But in order to do that, the calculating the data is the major important thing, and how fast and how accurately we can calculate that all application based, and it will varies from application to application, right? Because sometimes we just need a referential data of the terrain, and sometimes we need a more accurate terrain details of some particular area, something. It all application based, and based on that we can choose a particular machines and devices so to get a output of the desired models. So now next, talking about, okay, so generally lidar based are most accurate system, as I said, and usually they will comes up with the GPS and inertial navigation systems. And usually the output formats, as you have seen in that video, that is the reason I have showed that video. So what's the major general output formats we will get it from is a point cloud data. Okay, that's just a point cloud information which will be having a XYZ coordinated information with respect to one another. Okay, that means if you are starting some one particular point in the overall entire scan data, you can able to clearly see the dimensional difference from the one orientation to other orientation. So that can be used to calculate the distance or land mapping, what we call 3D land mapping. And one more advantage, as we have seen now, as the with Artec Ray, even during the scanning itself, it will capture the colored information as well. But till now, the technology is that you can integrate multiple from the different terrain based photographs. You can integrate that photographs to get a give a nearby colorful look to the polygon model. But again, when we say it's a polygon model, usually from all the scanners, it will be just like a point cloud data. And again, converting that point cloud data to a 3D model. Okay, just like just seeing it as a one surface, and in order to calculate a volume, so it requires much more time consumption in order to getting it converted. Okay, but in Artec Ray, we have all the features in one single software where we can do uh, till the till we getting the color information as well as also we can get the complete 3D model in the one single software. Okay, so now let's move on to the next slide. Just what we talk about the application. Let's go in detail about what are the applications. So one is a 3D modeling. Like 3D modeling, as I said, these 3D scanners are also used in the applications like BIM modeling or anything. Similarly, here also based on the required areas and required region. Okay, and also if it's any kind of plants are there which need to be scanned in order to accommodate particular machines, or you want to calculate the space requirement. in that particular application. So in that time, we can use the 3D scanners to build a complete 3D modeling out of it. Okay, and similarly, that mapping the entire terrain in order to calculate the how much water encashment it can do, and also the in order to calculate the flow of erosion. Those 2 points I'm going to discuss it in the next slide again. And also it will comes to maps the entire natural resources in and around. Okay, not only about the land but also on the surrounding environment. It might comes into a much more helpful in the applications like wherever the um, in the mountain region or the hilly region. Okay, there will be a terrain will be entirely different from one place to other place, right? So in order to calculate that, how to calculate the encatchment area and how it will go is going to help. Based on these 3D maps, we can sit at some time place and we can able to clearly understand the data. Okay, and then again, agricultural planning and management. That means in order to plan and manage the entire agricultural process. That means with the output of lidar survey, we can able to understand the which is the best, what I can say, which is the best method to which kind of plants might be best suited in this vegetation. And also based on the other methods like the applications of integrating with the multiple applications of electronic applications for calculating the weather and other regions, we can plan the um, what kind of crops can be planted. Okay, one more thing, similarly the land management. That means in order to get the more design and the map efficiently, and also in order to get the terrain details of the land. Similarly, the land segmentation. Now India is a kind of a land where the land segmentation is too high, because as the generation to generation it's moving on, the lands are getting degraded, like I can say it is getting divided generally, so that we can't able to uh, guess the application where we can able to completely apply the complete knowledge to one particular land, right? Because due to the segmentation, there are a lot of things we need to consider, and as the every profile will be in 3D, it is not possible to judge just by seeing the land, right? So in order to that, in the applications like this, that these 3D scanners comes into picture. Just by having a 3D details of the object, we can able to manage the land level, and also based on the crop what we are growing there, so we can able to correct that in a particularly in a scientific way. Okay, so again in the crop analysis. Okay, this is one of the example also I have pasted it here. Like lidar can also used to provide a general crop analysis and determine the sustainability of the crop to thrive in a particular farmland. This analysis is important to the farmers to estimate the crop quantity and measure this against the ideal standards. Okay, so when we say yeah, so just example, like when we think of the high yield product or the high yield crops, so what we think of that is that there will be an ideal condition or someone set examples will be there, correct? Because in particular region, so as we know that agriculture is a kind of a thing in which there are a lot of factors include the soil condition, as well as the water condition, the sunlight condition, as well as the uh, land terrain, all the matters, right? But again, when we talk about implementing the same facility in other place, there will be we will compare with respect to something which has been already established, right? What we call standard, that what we are telling it as a standard. So in order to comparing with the standards, we can able to map those things in a virtual world, and we can analyze it in a each and every crop level. Okay, each and every plant level. So that can be done with the 3D scanners. And as you can see this, there is one slide I have attached in the right side. There is a maize data scanned by terrestrial lidar scanner for the training and testing sites. Okay, so first the image of the A gives the size of the maize was manually segmented from the group and colorized by the height. So based on the height, they have given the total coloration. Like if it is less than this, it is in blue color, and if it is some certain height of some particular height, it is in green. And similarly, in order to analyze the growth of each plant, we can utilize this kind of technology. Okay, and similarly, if you can see the B, it has been categorized based on the sparse, moderate, and dense. It is depending on the planting density. Okay, so what are the different kinds of analysis we can able to study? Okay, that means if the plants are planted at different distance and what is it is affecting at a certain time. And similarly, if it is plants are planting at a different distance, okay, not in a denser way, it in a multiple, you giving a more space between plant to plant, and after certain time like 1 year or something, how it is affecting the plant's growth. Okay, in order to calculate that, we can do a 3D scanning at a different intervals of time, and based on that we can sit and we can analyze, and also we can also understand what are the factors which are affecting the growth of the plant. Okay, so that is one kind of application, and setting these standards we can try to implement the similar applications in the other applications in the other sites as well. Okay, and again determining where to apply the fertilizers. Yeah, exactly. So this is kind of application where you will be having a entire data or the 3D data of the land. Okay, and we know that due to the water supply or changes in the water supply after the fertilization is applied, so that will also affect the growth of the plants, correct? But sometimes if the terrain itself it's majorly changing from one place to other place, so we can't able to judge what are the kind of plants which need a more fertilizers and what will need a less, right? So in order to calculate that also, we can utilize this 3D scanning technology. And similarly, the field management, that is uh, mapping the water flow, right? Because as we are getting entire 3D profile, we can choose the which is the rightest path to make sure that the uh, we can make sure to calculate what is the best method to calculate the best method to give a chance to the uh, flow of the water, through making sure that the water has been easily supplied to the all the areas to or all the crops what we are going to plant in that area. Okay, so next is a detection of damaged crops. So again, this can also comes into a picture, like we can scan the some of the entire terrain. It's not only limited to one particular smaller area, okay, but it's what we are talking, it's a kind of a, where we know that the water scarcity is there, and also we know that the uh, for the different soil will be varies from one location to other location, correct? So in order to understand that, we can scan the entire terrain and we can easily store the data. Okay, and then we can use the same data to interpret what is happening in the furthermore years. Okay, so that means if that is a kind of a soil and the vegetation is like this, and again it is the same district might be, but again in the on the other side of the area the vegetation is different, and there you are getting a more yield. Okay, in that case we can calculate the you can understand the what is the reason it is affecting the damaging of the crops, and also it can also related one or other way for the production side also. Okay, so it can also understand the what kind of production we are getting in one particular area, depending on what are the new technologies we are provided and what is the modification we have did to the land. So those things can also be done with the 3D scanners. Okay, and one more major advantage is that the calculating and monitoring the soil erosion. Okay, as we know that soil plays a major role in means in terms of managing the soil is a major things, and this is a kind of applications like in order to calculate the land erosion, and also if sometimes there might be chances of landsliding, or if due to heavy rainfall there might be chances of landsliding also, right? So those things also can be calculated with the 3D scanners, and we can make a precautionary measurements. Okay, and that means if this is the kind of area which is about in a particular area, and if something is happening, how much it is going to destroy, and what kind of volume it is going to affect the land, and all those things can be calculated with the 3D scanning technology. Okay, and this is a one more example, like where there is no much more powers, what I can say, where there is no permission to scan the areas like the vineyards or other areas, where the and also in the applications like the estates basically. So they could not able to understand due to already the planted plants, they could not able to understand what is the soil condition, or what is the um, land erosion is happening beneath the trees, right? So in that applications also we can use a 3D scanners in order to get the detailed level of the mapping of the land area and the terrain. So based on that, we can sit and we can virtually discuss, and we can able to get a 3D model for that. Okay, hope these applications are clear. Any doubts as of now? about this lidar based 3D scanning technology, because this is about this, and let's laterwards we will directly move on to the applications of other applications of 3D scanners. uh, any doubts, anyone, or you want to any details, any explanations are needed in any of these the discussions till what we have did today? Okay. If there are no any doubts, I'll just move on to the next slides, where we will not talk on much on the agricultural side. And now the remaining slides are just to give a overall view of the application where 3D scanners are getting used in the in the industry. Okay. So let's get into that topics now. So now, where are these 3D scanners are used? Okay, other than using for the applications of reverse engineering and 3D inspection, and also for the applications like land survey on all other applications. Okay, so one major of area of attraction is that the heritage preservation, which is taking a more vital role in today's generation, as the generation, as the people are getting more interested about their prehistoric eras, and it is also mandatory to make it it has to be preserved in a such a way that it has to be transferred to the younger generations, right? For that also, 3D scanners are getting used. I'll just show it in the next slide how it will be done. And also, for example, like virtual museums, that means you can able to create a museum virtually, so that it can made it to accessible to everyone who are willing to utilize the technology. They can feel it in a real way, so that need not to go to some place and they can able to see it. Instead of that, they can clearly see it in the virtually. Okay. And again, next is the restorations. So restorations are something like if something has broken out and it has to be reconstructed, that also can be done with these 3D scanners. And again, archives and catalogs. So it's a kind of similar application, which I'll talk it in next slides. And as you can see this, even these 3D scanners are also utilizing in the industries like reconstruction. Okay, facial reconstructions also. That means if you are getting some skulls of a person or the king, so what you can do is that you can scan the skull, as those are majorly of more unique part in the world. So there might be chances of getting destroyed. Okay, right? If you are touching or if you're holding it in hand or something, so there might be chances of degradation, right? So in order to preserve that, you can scan the component of the skull, and you can directly able to 3D print. And on the 3D print or in the scan data itself, we can create a virtual face of the person, and based on the DNA details, how the person used to look like and all other applications, we can able to recreate, we can bring back the person how he used to look like so many years ago. And okay, based on the these digital format, digital platforms. Okay. And again, next, if I talk in applications like art and science, that means applications like CGI applications, architecture and fashion. That means, okay, let's go deeper in the next slides. CGI applications means for the applications of like graphical interpretation, or uh, if you want to add or some, if you want to take some character which is existed in physically to a computer world and you want to design something new on that. So for those kind of applications, and in VFX applications, this 3D scanner is also getting used. And also in the fashion industry, like in order to make a custom dresses for the celebrities, so they will scan the physical body, and they will take the measurements of the person in virtually, digitally, and then from that also we can able to create a complete uh, that is a kind of a business that some of the companies are doing on the art and science side. And similarly on the medical side, as these scanners are very much useful and very user friendly, so even the doctors are using these scanners for the applications like creating a custom braces. Okay, that means if one person is not having a leg, and if that has to be replicated, we can scan both the legs of a person, and whatever is distorted leg, we can replace it. We can make it in a custom fit for the already the healthy leg scan, and we can able to uh, subtract the area which is common in both of the scan data of the leg virtually, and then we can make a proper fitting connections, and based on that we can 3D print and we can able to use it in the applications as well. And again, wherever comes the applications of ergonomic or custom based chairs or customized anything, like if it has to be made like customized braces, or it might be for the backbone, or it might be for the hands or anything, we can use the 3D scanning technology. As everyone human anatomy is totally different, definitely there will be need of something where it has to be customly built, correct? So for all those kind of applications we can utilize the 3D scanners. And also in the applications like plastic surgery, that means as some of our scanners are also able to give the final output with the real color, we can scan a person face, okay, and based on the scan data we can uh, the the person or the doctors who are on they will only modify the face in virtually first, and like 3-4 different approaches, and they will show the same faces to the customer, and they will make sure that which kind of they want to look like. That means it's just showing the person who is going to undergo the surgery. They will show them how they are going to look like after the surgery is happened. So based on that they can make a decision how they want to look like in virtual world, and it's their own face, right? It will gives more value to them, and even it will converts to a measure much more business to the um, medical industry. So that is one kind of application. Let's discuss about the similar kind of applications what I planted in another some 2-3 slides. Okay, yeah, so this is a kind of applications for the digitization what we call. So that means if you're already having existed monuments or other applications which are under the threat of degradation, because as we know that due to acid rain or other kind of multiple factors, and also maybe the human much more human encroachment, so these are a kind of monuments which are clearly protected, but still there might be chances of due to earthquake or something, and there might be chances of getting degraded, right? So in order to prevent that we can 3D scan the entire buildings, okay, and we can preserve it digitally. So that means even if something happens, or if you want to re-replicate it at some other location, we will be having a 3D model of it, exactly precise model, and from that model we can able to recreate it, okay. And again, that is one kind of what we call archiving of the uh, existed models, okay. And also we can make a digital labs, or what we can say digitally libraries, where we can store the systems or the store the data models, and from that we can able to utilize, and we can make it available for the people who are interested to learn more about the, it might be architectural way, or it might be on to understand the historical events. And also sometimes even there might be some writings or the paintings which are written on the walls, right? As our scanners are also capable of giving with the color, even that can also be analyzed digitally, and it can be make it accessible to everyone who all are interested, okay. So as I said, one is digital restoration itself. That means if some monuments is already broken out or anything is happened, so in order to create that, you need a reference models, right? So because if you can see this, there is a top portion has been completely broken out, and some of the Gopura areas has also worn out. So what we can do is that we can take the reference from the already where the design is clear, or the still the structure is clear. The same can be replicated digitally, and based on that dimensional details we can give it to the restoration people. They can able to restore it in a much more understandable way, and in more accurate way, as they have built it in a prehistoric time, okay. And similarly, as I said, we can use the 3D scanners for the applications like video games also, or the what we call say virtual applications. That means if you want to create a scenarios as it is, that means you want to include the surrounding areas of some major historical places, or it might be some of the terrain. Maybe it might be some terrain, like if you can see the games like PUBG or any other applications where they want to include the terrain. So that also 3D scanners plays a much more easier way than creating a CAD models in a digital world. Okay, that means in order to create a digital CAD models, you have to rebuild the design, and you want to it itself, it's a too much of time consuming process. But instead of that, if you are, yes sir, hello. Okay, so if at all that is a more time consuming process, instead of that, again it might require a lot of back end process to uh, sir, I guess I'm hearing some noise. Okay. Uh, okay, let us proceed. So what actually I was saying is that if at all some when we are assuming that the same kind of scenario what I have shown in the current slide, if you want to create a same kind of digital models, so one should be having a complete architectural knowledge about that particular terrain and that particular historic events. So then only they can able to get the models, right? But again, creating the models in a digital world itself, it's a too complex, time consuming, because it's a nothing but a design process. Some multiple designers have to sit and they have to build the models as per the design consideration, like this is the length, this is the width, and this is the some of the features I need to add. So it's a lot of time consumption process. And again, adding the rendering models, that means when I say render, rendering is a process of adding the color informations to the 3D models. Okay, uh, but as we are building the designs in a computer or CAD oriented softwares, rendering has to be very manually. Okay, you might have if you are anyone or have any interested on the AR/VR applications, you might already know. So just to render a one particular object, it takes a lot of time. Okay, but similarly, if you want to create the entire scenario, so you can imagine how much time it will take, right? So in order to reduce those kind of make it as a more time saving and with a more accurate realistic models, we can use a 3D scanners. Might be it's a long range scanners, or also it might be utilizing the handheld scanners also. We can get a 3D model or the 3D environment as it is. And also we can the major application for AR/VR application is the size of the 3D models. Okay, that means when we are uploading to the 3D models to a particular platform in a web for platforms, there will be some particular polygon count has to be very much limited. Okay, so in order to considering all those applications, these 3D scan models can play a role, and definitely it will require some more additional softwares in between. Just like just by scanning we can't able to use it for the reverse engineering, right? Because as we discussed, it has to go through a process of reverse engineering, where we will change the dimensions of the object manually, or just by fitting the surface automatically, depending on what our application is. Similarly, here also the application is same. After the scanning, we can take the 3D models to these softwares like Maya or Blender or any of the other rendering softwares, where we can do the change necessity changes. But here the advantage is that as these scanners can able to give you the final output with a real color. Okay, we can able to directly utilize the same model, which is almost like a 70 to 80% or 90% ready models in terms of for the direct AR/VR integration. Okay, so that is a kind of what we are advantage with the these Artec handled 3D scanners in the applications like this as well. Okay, and next, just for the virtual education. Okay, as we know that it might be not only it's limited to the medical field, there are still a lot of companies also who are utilizing the 3D scanners for the applications of for the educating the their students, or educating their scholars, or also for the their internal teams. I'll tell you how for in this example what you can do is that as for the medical side, I'll if I say getting the cadavers are very difficult, right? Because they are very limited, and when they make students or their medical students to work on the actual body, so it might be very limited as availability, and if it's something goes wrong, they can't able to get it back, right? So in order to before they practice on the real bodies, they can able to uh, virtually they can train first based on these 3D scan models, and they can understand what is a what nerve and what is the need to be area need to be dissected. So based on that, they can first they can practice virtually, and they can act on the real organs in the later words. Okay, in order to make sure them they're clearly understood the concepts, we can use the these kind of technology. And similarly, as I said, these scanners are also utilizing in the applications of training in the industry level. Okay, when I say industrial level, one is might be if the applications like some person particularly for let's say if the person has to go to some location and he has to do some particular machine fitting. So instead of making him to just go and act on that location, they can train him virtually by creating the entire scenario as it is. Okay, that means for let's say if a person has to go up on the windmill. Okay, you might be knowing the windmills. So there are very much complicated areas where it has to be more precise and time will be limited. So in that case, instead of person directly going complete there and giving a training is also much more difficult on the on board. So instead of that, they will create the entire scenario, including the wind turbines and all other things, and each and every machines which are fitting on that. And in order to do recreating that machines, most of the time, the manufacturer of the turbines or manufacturer of the motors or what are including, so they will only provide the CAD. But if at all, if the CAD or if the design is not available, so they will utilize the 3D scanners in that application, and then they will recreate, and it will integrate to the virtual environment, and they can the person who is going to train or the person who is going to work on in real field, so they can be trained in a virtual world just by holding with the haptic devices or the holding devices. So they can train it here virtually what is the nut and they need to, and what are the precautionary measures they have to take care in order for them to not fall down. Okay, so all those kinds of things can be are generally going on with the 3D scanners. Okay, so again on the medical field, if I say just for the on the dentistry side, like they can scan the person's face and they will scan the area of the teeth also. So this is just one example which are not to your related to your application, but just to give an overview idea of how the 3D scanning business or the 3D scanning applications involves in all other applications. Okay, uh, so what they do is that they will just scan the intraoral with the intraoral scanners and the just a facial expressions with a normal these handheld 3D scanners, and they will just make sure that how their future teeth is going to look like, what we call the implant, so how it is going to look after the operation is done, and they will just take a approval from the customer, so it will makes them to feel more happy and more confident about how they are going to look like after the implant is done. And similarly the applications like ears or in order to replicate the ears. Okay, what we call microshia, so that means you can scan the healthy ear and we can mirror the to the other side where the ear is not fully grown, that that condition itself, it's called a microshia. In order to treat that, we can use the 3D scanners are the must, because you can see that the ear and all the involutes, so those are very unique, and it is varies completely from one person to other person, and it is not at all possible to uh, get the exact dimension or get the exact replica by any other means. So one proven method was that using the POPs on the ear and getting the mold out of it and then doing that. But again, it is a usually it's a when the microchip has to be treated in for the children's itself, even when they're in the when they are small. So it is not possible to make sure that to get the cast with the other methods. Now with the utilizing 3D scanners, we can able to get a complete 3D profile within just minutes. Okay, so then it is much more convenient and which is more accurate for the replicating the methods. Okay, and in India also there are a lot of medical institutes are using for the similar applications. Okay, yeah, so that is a 3D printed. Here the application is different, which has been done in the other not in India. What they did is that they are 3D printed the ear with the stem cells of the same child. Okay, so that means they will making it as a real working ear, but in some time it might be in India and other places what it is happening is those are like a prosthetic ear. They will just make it as just to fix it there, and they have to just make it to look like a similar exact real ear. Okay, yeah, so again in the applications like virtual meetings, so these things are not limited to industry like the museums. Even this can be utilized in the applications for the uh, institutes itself. Okay, that means if some of the unique designs, or if you are already having a unique models or the statues in house, so they can scan it and they can collaboratively work. They can transport it to the different organization where they want to 3D print, and they can make it available to their students and also their scholars. Okay, so those kind of facilities are available. And in this example, it is kind of a museum. That means every features are unique, and when they're in a display, there might be chances of getting destroyed, right? So in order to avoid that, they will 3D scan, and they can keep a replica of that, and from that replicas they will transfer to other museums where they will 3D print, or by other means they will recreate the model as it is, and they will make it available to the people who are visiting them. And again, the same 3D scanners are also utilizing in some of the applications like prehistoric area for the excavation applications, where what we can say, where they will as the excavation is going on, they will scan the site in real time. Okay, so that each and every scenario what is getting captured can be uh, calculated in a 3D world. Okay, that means when we are there when the students or the people who study those things, so they can't able to judge, because if you assume if you are having a multiple camera images, so something which you're studying with the camera images, and something we are sitting in a room and you are just zooming in and zooming in out, so there is a completely different feel, right? So those kind of applications are also going on with the utilizing the 3D scanners. Just like that, let's say if some bullet is penetrated, even that also can be calculated. So that is the reason these 3D scanners are also utilized in the industry, like forensic applications. Okay, in India it is just in a discussion stages in most of the institutes, but if I say in other countries like US and in the other Europe countries, they are using these 3D scanners as well as long range 3D scanners for the applications for the forensic also. What they do is that they will scan the entire crime scene as it is, and they will sit and they will calculate what is the distance from this to object to this object, how far it has been felled out, and if it is a murder scene, how the murderer might have jumped on, if he has departed, how faster he could have went, and if it's any bullet holes are there, okay, or the bullet wounds are there, how much depth it has been, even if they can able to calculate the projections of the bullets also. Okay, so till that level of implementations are going with the 3D scanners. Unfortunately, I have not added that slide in today's session. Otherwise, I would have shown that video as well as the audio also. Okay. So again, as I said, virtual tourism is gaining more popularity in these days due to, let's say, for the pandemic hit, after people cannot able to go and visit to the locations. Instead of that, the virtual tourism gaining a more popularity. Even the virtual tourism are in some level like just they will do a video camera and they will make it available, but okay, there are applications like with the 3D scanners, they can able to replicate the even the minute details also of the object, or let's say if it is a complete temple structure is there, uh, with the 3D scanner, they can make it as a complete walkthrough into the temple, and even you can able to zoom in and you can see the even minute feature on the sculptures also. Okay, so till that level of field they can able to get it with the 3D scanners. So that is the reason most of the some of the temple trusts, not only in India, in other museums or all other places, so the virtual tourism is gaining more popular in these days. Okay, and one more major application is on the e-commerce website, which is nowadays this is coming up with a multiple new way of approaching with the customers. So what is happening is that in an e-commerce website, if you have some artifacts or very unique applications, you can scan and you can upload it to the 3D platforms. Okay, that means instead of making a video of the object, you can make it as you can upload a 3D data itself of the real object, so that will makes more realistic feel to the customers, and who all are about to buy the product, they can feel it really and they can able to make a decision. And again, this is not only limited to artifacts or anything, even um, automotive industry or the equipment manufacturer are also utilizing the technology. Why? Because in order to make particular walkthrough video of the entire product, they are also using these 3D scanners. Okay, and let's say if you want to create some kind of catalogs or anything, and where there is a creating a CAD is a more time consuming, in that case they will use a 3D scanners as a basic input, and then from the 3D scan models they will implement the component over there. Okay, yeah, so that is about it. And again, one more application is like scaled down 3D printers or 3D scanners. So what it is that if some kind of very unique features are there or some artifacts, let's say like just like as I said, some unique statues are there, so we can scan it and we can make it as a replicated models of it. That means instead of creating 1:1, we can replicate, we can duplicate, or we can sampling it down, and we can make it a 3D print out of it, and we can make it available. Okay, so this is one of the example, like inscription stones. What they did is that they have scanned the inscription stone and then they replicated it, and they will even the letterings what it is written on that, that is also actually it is almost like 1.5 to 2 meters big part. But with the after 3D scanning is done, the application is not only limited only at that end, so we can able to utilize it in a multiple way, and this is one kind of it. So they can replicate it and they can make it to available to make it to giving it to a people who are attending some kind of functions. Okay, this is a uh, giving it as a present to the people who are attending that particular historical event. Okay, so similar kind of things can be done with the these 3D scanners. Okay, yeah, so this is one of the example how it will happens, like if you are uploading to the 3D models or in a virtual world for the applications of e-commerce or other applications. Okay, and now let's, before concluding this today's session, I just wanted to add some points on the our other products as well, just to give information. Like till now what we have understood is that with the 3D scanners, what are the possible ways to where we can implement these 3D scanners. And we have different 3D scanners for different applications generally, like say every scanner has its own capacity, and every scanner it has its own kind of modeling method. And already we are discussed about the glossary also, that means what are the basic parameters of the 3D scanners, and based on that we can able to select a suitable scanner for a suitable application. Let's say like if the object is very minute, smaller, like less than some 5 to 6 mm, it is not possible to scan from the other scanner, right? Because the resolution itself, it's a varies from scanner to scanner, and we have to having a proper control over the model what we are scanning and what kind of applications we are going to use after scanning is done. So based on that we can choose a particular scanner to get a particular model and the desired output. Okay, and similarly if it is a long range scanner and if you want to scan the very larger components, it might not be definitely it is possible from one the same scanner, but uh, if the length is increasing, the size of the size of the component what we are scanning will totally increases, so that you should be having that much of high-end system to process that data. Okay, that's a general rule. So that is the kind of a decision what you have to take before we approaching to any of the projects. Okay, and applications. Okay, and again just to conclude about before today's presentation. So just I'll quick recap what are the things we have did till now, and we'll just conclude it now. And these our Artec handled 3D scanners are one of the most. Am I audible? Hello.
Hello. Yes, sir.
Yes, sir. Okay. Actually, what I was telling. Yeah. So these Artec 3D handled scanners are very easy and very easy to use. It means as the weight is less than 1 kg with EVA and Space Spider, you can go to any location, you can easily scan the components and you can get the 3D model out of it. Instead of the traditional methods like you have to bring a part to the lab condition and then you have to do the scanning. So those kind of things are not present here, because as the scanner also comes up with a battery pack, you can go to any location where you can easily scan. Okay, and you can get a 3D model out of it within some minutes. Okay, and as a one more advantage is that no markers and calibration is required. That means as I have explaining in the first day itself, that means there are different products also. That means if when we are moving from one location to other location, generally you need to do a calibration, what we call. That means you are just checking the machine whether it is working, it's in complete optimal range. Okay, so in order to do that, because those those equipments comes up with the detachable machines or detachable lenses. Here, as everything is totally fixed, okay, you don't need to do any kind of calibration. That means you don't need to do any initial checking before you start the scanning. Okay, so you can just make a connection, you can directly ready to go scanning. Okay, what we call plug and play scanning. Just make a connection, just start scanning, and you can digitize the component. And one more thing is no markers is required. Why it is so means, as I explained, there are different kinds of methods to track the component, and our scanners are equipped with the geometry as well as a texture based tracking. Okay, that means it will captures the geometrical distance existed in the object what we are scanning, and also the color details. Okay, even if it's any color difference is there, that also will be calculated with the uh, our scanners, which will support the color as a input. Okay, and then yeah, the major advantage, as I said, the lab temperature is not required. That means it can be operable at in any temperature less than 55 degrees Celsius. So which will be even more user friendly, even if it's in a shop floor assistance, or if it's in a open environmental condition. That might be for your application, it might be the sometimes you might need to go to a former place or any place where you need to digitize the equipment. Okay, so let's say if it's some traditional equipment is there and you want to make sure to document that, and you want to recreate the design of the same kind. Okay, in that case also you can go to the location and you can scan it, and you can do the reverse engineering or the redesign in the with the design team, and we can able to get it. But in order to do that, the scanning is a major plays a major role. So we can go to that location, we can scan it without anything, and we can able to get the model. Okay, and one more is a speed, as you can see in the videos also. So the speed of the scanner is very much faster, as it takes 2 million points per second in terms of eva light. And with the other scanners we can able to achieve up to 35 million per second also, but again those are for different application. Okay, and so as it's a covering area is also very much larger. Okay, means that the capturing area is very much larger, so you can able to scan easily 3-4 meters parts within very less minutes, like with less, let's say some 10 to 15 minutes you can able to, or even within 30-35 minutes you can able to completely scan the tractor or any of the equipment, agricultural equipments. Okay, and similarly, as I said, the Artex Studio, which is our software, which is having a much more advantages of giving a much more output formats. As I said, some 10 to 11 different output formats, which are like a ready-made input output formats for the different softwares. Okay, so that's the kind of good resoluted models what we will get it from our scanner. And then just to conclude, before that, the tools what we have discussed till now about the all these day 2 and day 3. So that's the kind of tools which will ease us the person who is using a scanning and reverse engineering. Because if at all, if you're scanning larger components, your time should not be limited. Okay, that means you should not suffer a months together of time to get a 3D model of larger component, right? So that kind of errors or that kind of time consumption is not there with these 3D scanners. These are our Artec 3D scanners, where the software is also very much faster in application and in working way, and also handling a huge data set. Okay, um, so that is one application. And just to conclude before today's session, I guess I'm near to the end of my session. Just to before conclude this, what actually I just wanted to add is that um, okay, so want to conclude that these are a professional handled 3D scanners which are based out of Europe, and this is the, as it's a professional handled 3D scanners, you can digitize any of the component, whatever of your desire, of your area of interest. Okay, it might be kind of whatever you look around and you feel that you need reference of that model for some particular application. Okay, it might be for reverse engineering, or it might be for inspection or anything, or you want to take reference, just a reference of that, or you want to digitize that model. So all the things can be done with these 3D scanners. Okay, and then within a very less time, as well as with a much more in a broadened way. Okay, and also after 3D scanning is done, what the next step is that if it is a reverse engineering or you want to get a CAD oriented models, so then we have to go through a process of reverse engineering where we will convert the each and every dimensionally. We will constrain the sketches. If it is a parametric modeling, that is a manufacture level of design. Okay. uh, and if at all, if it is not a manufacturing level of design and there is no need of changing the design parameters at all the time, what we can do is that we can use some other methodology like creating a what I can say, creating a 3D model with the reference of um auto surfacing, or what we say, custom fit modeling. Okay, that which is a second method of approaching. That means fitting a surfaces on the scan models and then getting a 3D model out of it for the documentation, or might be for the manufacturing level in one or other way. Okay. And then the third method is that getting the 3D models directly for 3D printing. So that means you can create a 3D model in the software itself, where you will get a complete highlighted or completely dense or solid model from the scanning software itself. You can customize that as well, and even you can customize the resolution value of the output what you are designing. So based on that, once the model is ready, you can feed to 3D printers directly, or if it is any changes need to be done, you can utilize that. But let's say assume you are designing something and or you want to do analysis of that. Okay, that means you are designing some new AG vehicle or some machines, and you want to understand the what is the pressure load, or what is the outlet value of the exhaustive system. So you can scan that particular system, and then you can take the scan model and you can apply a auto surfacing method to get a CAD model for that. And then the same models can be taken to the analysis software like ANSYS or any other softwares, where we can analyze the different kind of methodology. Okay, even though you don't have a CAD, because you are doing some research on the existed component, right? Because as the time is limited, you can just scan it, you can take that, and you can do the analysis of that as well. Okay. And then that is about the reverse engineering along with the 3D scanner. Other than that as well, we can use for the inspection also, like once the part is manufactured, once your design is ready, and you are before you going for the integrating with one or other existed components, that also can be, you can validate it in a computer coordinate. And then, as I said, with the long range terrestrial scanners, there is a different kind of applications. And yeah, I forgot to inform that one of the major disadvantages of lidar based scanner is that the cost is too high. Okay, compared to other methods or any of the other methodology what is existed, the cost of the lidar method is high. So that is the reason it is very limited. And even in some countries, the government itself will, or the particular organizations or the surrounding institutes, they will scan the things and they will make it available to the people who are living in their area. So till that level of uh, improvement are going on with the 3D scanners in applicating to the agricultural field. And yeah, so that's it. And as I just before conclude, these 3D scanners are a professional 3D scanners, and it can be visible in all the applications. And even if you want to integrate with some particular any of the field, you can able to utilize it in all the possible manner. Okay. Yeah, I guess that is it. I'm just hope this all the session of all these for everyone in order to understanding what is 3D scanning and how the technology is. Because in sometimes what people will tell like that, just by scanning you will get a CAD model, or you will just by 3D scanning you will get a complete output of that. So and you can directly go for manufacturing. It will not work in that way. So that is the reason we have completely, we don't want to, we want to educate the people, and we want to make them sure to understand what their application. And we are ready to support the team who are ready to uh, share their ideas, and whatever the end result they are looking for, we are ready to always ready to help in that way. Okay. And this is it from my end. Thank you everyone. Thanks for giving much more opportunity, Mr. Kemchan sir and the NAHEP Parbhani. And just now I'm just concluding this session, 5 days of session, and you can just ask me any of the doubts you have, or anything. We are still have a lot of time, so we can discuss on that now.
All participants, as we have a time to conclude for the session, that is in the valedictory session. It is for you that this particular half hour is taken for the question and answer session. If you have any query related to 3D printer or 3D scanner, whatever else, Lakshmikant maybe try to rectify. Okay, so you can
Yes, sir.
ask your questions.
Hello, sir. Hello.
Well, sir, you can ask the question.
Hello. Hi, sir. Yes, sir, you are audible, sir. Actually, my mic was on mute, so just unmuted myself.
How we can using 3D scanner technology in food processing?
In food
Because-
processing. Okay. Okay, sir. Actually, in food processing, as I said, still, if you want to do any kind of designs which we related, taking some reference. Okay, 3D scanners comes into picture when there is a references as need to be taken care. Okay, so in that case, 3D scanners plays a major role. So in the applications, as I said, we work with one of the company where they wanted to do a create a sieving machine. Okay, that means sorting machine. Just generally, they wanted to sort particular kind of rice. I said the same example last time also, so it's the same example. Like they will scan the grain of a rice, okay, and taking that as a reference, so they will make a complete sieving machine, or whichever is having a particular dimension, okay, which is a standard, which will make more standard to the customer, which is not available in the market. So they will take the dimensions as a reference, and which all are able to pass through that particular dimension will only see through the different levels of machines. Okay, so they have made some 4 or 5 different layers of machines, and then there they have can able to utilize that size as a basic input, and they've been doing that. And again, one more example of what I had was that I forgot to add. It was in the food packaging industry, not in here, but again in the food packaging industry also. One is in the customizing the robots and other things, and also one more is that in order to packaging. Okay, that means if at all there is a kind of a chocolate or any kind of applications where they want to create a covering, okay, just a custom based covering for that. So in that also application they can able to utilize the 3D scanners. Okay, but particularly if I say about food processing, I guess I am not getting that much of ideas right now, sir.
But yes, sir. In relation with the food processing industry, if we have to fabricate the machines, because in food
Correct.
processing machining there is also some types of machines are there. If you have to fabricate, so that machines can be able to replicate with the help of these scanners. If you have procured or imported any machinery related to food packaging, so food and food packaging or whatever else, so you can import that machines, and then if you have if you unable to get the dimensions of any of the product, so that dimensions could be scanned, and you can be able to reverse engineering. That is the motto of this training, that you can reverse engineer that particular machines with the help of scanning. This way you can do in the processing industry for the fabrication of machines.
Exactly, Kemchan sir. So definitely it is a cost saving. Why? Because in all the food processing industry, investment will be a huge generally, right? So in order to getting the return ROI or anything, if at all some kind of replacement is must needed, definitely replacement will be needed. And also sometimes you want to customize your own designs. Okay, that means you understand that the existed methodology is not working, and you are wanted to add some design to it. Okay, or you want to fabricate separately and you want to add it. But when in order to create a redesign, you need some reference of the existing models, correct? So in order to get that, we can 3D scan, and we can, as Mr. Kemchan sir said, we can takes that, and we can able to, taking a reference, we can build a customized. So that means like where exactly that has to be fit, like, okay, where that new instrument what you're going to do, it might be kind of a stirring machine, a stirring label or something. So where it has to fit in order to work for a much more efficient way. Okay, so yeah, so that's it from my end.
Hello, I'm Ashutosh. Okay. I'm a farm machinery and power engineer. My main
Hello,
field
hi
is
sir.
farm machinery and power. So our
Yes
role is
sir.
to develop agriculture machineries
Okay sir.
that can be operated by the population, which is covering most of the population, means all women and men, right
Oh,
from
okay.
is 18 years to up to 60, 70 years. So each and every person having different body size, body dimensions. Okay,
Correct sir.
we design our machine as per such a way that it can be utilized by most of the population. Okay, so for that we have
Okay.
one area, that is ergonomics, and
Ergonomics. Okay.
in that ergonomics, and in that we measure the anthropometric dimensions of people. Okay, so
Okay.
in some studies we used to measure anthropometric dimension of about thousands of people, 1,000, 2,005,
Oh,
maybe 5,000. That much of database we used to take, not myself but my colleagues and our in our institute. So can we use this 3D scanner to take body dimensions of human being?
yeah, definitely, sir. Right now, how you are doing that, taking the dimension, sir? As you said, it might be needed to take some number of people. But currently, how you are taking the dimensions of the people? Hello. Uh, I'm not sure
Yes.
who was asking the question. I forgot the name also.
Hello, Mr. Ashutosh. Mr. Ashutosh.
Yes,
Mr.
sir.
Ashutosh. Hi,
I
sir.
want another call, please. Uh,
Yes, sir.
what do you want to say?
Actually, I was asking currently how you are taking the dimensions of the
Physically,
humans
we are taking physically dimensions using
physically.
tape or like that, huh?
Okay, okay. But sir, if you want to document it properly, and if you have some plans of you want to do kind of analysis in the digital world itself, okay, because right now you're doing with the taking a dimensions, and you're noting it down on somewhere, and you're averaging that. Instead of doing that, what you can do is that definitely you can use a 3D scanners in that application. But it all depends on, like, 3D scanning will happen of a person within some 2 or 3 minutes maximum. Okay, you just make to fix a posture of a person, and then you can able to clearly 3D scan the entire person. But on the post processing side, it will takes at least almost around uh, another 5 to 10 minutes in the back end. Okay, that means within a time of 15 to 20 minutes you will get a complete 3D image of the person. But if you are assuming you want to do it for some 1,000 people, okay,
Huh.
uh, it is possible, definitely possible. That means you can, whenever you can get an appointment, you can scan everyone, and you can keep a digital copy of that, and then you can make it, what we call processing in the backend. Okay, but
Huh.
what my suggestion is that if you are uh, if at all the person's total dimension is needed, and it has to be documented, and clearly documented, and also you want to use it for the applications, like you want to use it for the analysis also, then it is a best suited method. Okay, but you want it just only for one dimension, one particular dimension, and you want to average it, better it might not be that much best solution for the persons of 1,000. Okay,
No,
considering I'm taking a count of 1,000.
we used to take complete body dimension of the person. Means
Okay.
this is for one or two dimensions for particular one or two purpose only. But if
Okay.
we want to we have sometime we develop a database of complete population. So
Okay.
maintaining the body
In
dimensions.
that case, okay, in that case, definitely 3D printers, 3D these 3D scanners are comes into play, sir. Okay,
What is
that
the
means
accuracy?
if you once you, yes, sir.
What is the accuracy?
So the accuracy of the scanner is 100 microns.
Okay. Okay, that is enough.
But but yeah, but what's the advantage is that once you get a 3D scan model of the person, okay, you can able to take any of the sections at anywhere. Okay, that means if you want to take a shoulder section, you can just take a section over there. You can able to measure the dimension in virtually itself. and even you can able to save the data also.
Okay.
So but yeah, so definitely it will be useful if you are if you are planning for some kind of a futurist, you want to develop some database in a futurist stage, definitely these 3D scanners will be much more helpful.
Okay. Thank you.
And let me to add some more example, like even some of the companies who are using for the, let's say, just like as I shown in the video of yesterday's Vortex video. So in order to do the analysis, okay, because analysis of a vehicle, or if it is it has to be operated by a person, okay. So definitely some of the analysis has to be done on the person also, right? Because in order to reduce the drag and all other cases, in India also some of the clients of ours and also some of the customers who are using for the same applications, okay, they will make the rider to sit on that particular vehicle, and for different orientation. Sir, 1 second. Sorry sir, actually sitting very near to the main door, so that's the reason I'm getting a lot of noise actually. uh, okay, where I left it, yeah. So what actually they do is that they will scan a person along with the various posture on the vehicle itself, and they will calculate the what is the amount of drag, or what is the amount of the person's height also, or the body or the posture affects for the movement of the vehicle, okay. And based on that, they will also change the design in the for the vehicle itself, or also on the mounting positions, okay. Let's say if you see some bike, sometimes if it's in an Enfield, the bike of the posture of a person, it will be like sitting in a straight, right? But if it is a bike like R15 or other things, you have to be completely bending on the near your head will be near to the tank, right? So those kind of analysis can be calculated based on the using the 3D scanning technologies, okay. And also some people use the same scanning technologies for creating a mannequins for the promoting or marketing applications as well. They will 3D print the entire structure, and they will use for the promoting that as well. Hope that is clear, sir, my answer.
Yes, clear. Thank you.
Thank you, sir. And I guess some questions in the chat box, I guess. Excellent. Thank you. Okay, how much does it cost to 3D scan an object? Sir, it all depends on the time what we are spending on the scanner. But as you are already having it in-house in NAHEP, it might be easier for you can discuss with Kemchand sir once how we can proceed it further. And
Yes,
but again, general.
for
Hello.
the NAHEP participants and the faculty and students of the NAHEP Parbhani, and anyone whichever will be present with us, they want to do their experimentation on this laser scanner or 3D printer, it should not cost any single rupee, okay. As we have a device, and this device is for the students and faculty of development of the students and faculty of the student of the VNMKV Parbhani. So they will not taken any money from for the scanning of any object. If they want to do the case study or any experimentation, they can just come to the center. They can contact us, especially me. I will help you to scan the object. This facility is for all the participants, all the VNMKV faculty and students. For this purpose, this project is established.
Yes, actually, NAHEP has taken a wonderful initiation on implementing these advanced manufacturing lab in the NAHEP. So definitely, I'm request everyone to make use of it in one or other way. And technically, they are very much advanced, and also they are having a proper vision about what they wanted to do. So please collaborate with them, and you can definitely you will get with the your end result. But in order to just to give a rough idea about how the industry works, is that it will just outside of the situation, it will works like what kind of job you are scanning and how much time it will take. Okay, so based on that, the time of scanning and the post processing, and also the output they're expecting, so based on that the cost will be decided. So that's it, sir.
Whether this 3D scan object, can it be processed in any reverse engineering software, or we need to have this specific software for this object scan with this printer scanner only?
Okay, no sir, actually uh, I guess I explained it in the some other sessions also. So I'll tell you clearly. See, it is like the scanner, particularly what we have supplied, which is Artec EVA Lite. So what is that the scanner, whatever the data it is capturing, that can be stored and it can be analyzed in the Artec Studio only, which is a post processing software. Okay, so Artec Studio will converts those raw scan data to a polygon model. Okay, so what we call that's a triangulated mesh model in general. So these triangulated models can be exported to the formats like STL or OBJ or PLY. Those are called a neutral formats. Okay, so if your software, what software you are using, and if that software is supporting importing of these neutral formats, as what all I just said, STL, PLY, or OBJ, or these formats, so you can import it in your software and you can able to see the output. Okay, but if your software or if your design software which is having a reverse engineering module, okay, that means let's for example, if you are using a CATIA, in your CATIA there will be multiple module, correct sir, like part design and generative shape design, right? Similarly, there is a particular model for reverse engineering. Okay, if you have that particular model, then you can able to work on the 3D scan model. Okay, otherwise you can just only able to see the output of the 3D scan, but you can
Okay.
able to import in your software. Yes sir.
Okay, got it. Thank you.
Okay, thank you sir.
Anybody related, you can ask the questions.
Yes, still we have a lot of time, I feel.
Yes, yes.
So I just
If
finished it earlier.
if you have any idea you want to implement, or any case study you want to do, you can ask right now.
Yes, sir. If you have any, yeah, if you have any some simple idea and if you're thinking how to make it in reality, okay, just you have some concept design and you have wanted to do some kind of machines from this to that stage, and if you are feeling some struggle or if you have stuck with some ideas also, you can just ask us and we are ready to help out on adding our ideas to that.
Sir, my question is that
Hi,
in
sir.
your
Hi, sir.
even you in your slides you are showing that you are scanning the crop. So it is possible to fix this scanner to the drone for the scanning of crop.
No, sir. Actually, okay. In order to scan the crop, all right? No, that is, I'll say no. Why? Because these are just a handheld 3D scanner. What the scanner, what we are supported to your application. So that is a handheld 3D scanner. So that will be, it has to be holded in hand, and it is a completely portable scanner. Okay. So, but if you want to scan some kind of crops or anything, we can do that. But it's better to know what is the end application. Okay, then we can able to think on, we can able to do it, sir. Okay, but if it is just a crop, and how much land you are wanted to scan, that is a one major question I wanted to ask actually. That means when you say the scanning of a crop, whether it's a small amount of the crop or you want to scan the entire land site or anything. Mr. Dr. Hemant sir.
Sir, entire land side.
Okay, no, sir. It is not possible to scan the entire land size, because as these handheld scanners are just like a, it's not a lidar based. Okay, these are a normal structured light scanner, so it can't able to penetrate through the crops and it can't able to get the terrain details. Okay, it can only able to get the area on which what the light of the scanner is falling on. Okay, but if you want to scan some kind of crops or anything, even if you want to scan some leaf or anything, it can be possible, but you have to make it to make sure it has to be hanged out in some orientation so that your scanner can able to turn around the object. So definitely in that case we can able to get the 3D model of that, but it is not possible to scan the entire land. Okay.
My another question is that
Yes, sir.
last time we have our Indian mango season. The most of the
Indian
fruit in
mangoes.
India,
Okay.
the mango season, most of the fruits
Yes,
are
sir.
affected by the fruit fly. So it is possible
Okay.
to scan by 3D scanner and detect the damage quality and damage percentage in the fruits or
Okay.
effect of their fruit fly.
Okay, sir, for that question I will say no. Why? Because you can able to just get the size or any. See, these scanners are basically, sir, I'll tell you, these scanners are only geometrical based scanners. Okay, it can only able to scan the geometrical details of the object. Okay, but it can't able to give any idea about what is happening inside, or if it is any uh, if it's any color difference is there that you can visualize. Okay, if it's a scanner is with the actual color, okay, you can able to visualize with the color, but it can't able to, software will not, or the scanner will not directly give you the output telling that this is what means this is what the errors are existed. But you can just only you can just you can able to use the scanners just only to capture the geometrical dimensions if any application is comes into picture.
Okay, sir.
Okay.
Yep.
Okay, thank you, sir.
I would like to share some scan model with us. As you are you able to see my screen? Uh, I would like to con convey to all the participants. As you see that this is what the model we have prepared in at our center through our Take Your Light. You can see this model of the human being as we have created. We have also created one of the model of honorable VC sir of this university. I would like to open it. This is what these are the frames we have taken for this particular session. We have taken the 5 to 6 times scan for this particular model, and we have generated this model. You can see
Hello. Uh, Participant
Hello.
have any question regarding the 3D printer and 3D scanner? Please ask. If the participant have any question, they also type in a chat box and ask to the sir. Okay, sir. I think but no, there is no question from participant end. So
Okay.
I have thank you to you and take a short break for 5 minutes and we will continue on validator section.
Sure, sir. Okay.
Okay.
Thank you, everyone. Sir, I guess just to add one point of mine, I
Okay.
remember there is one case study on to detect if there is any infections on the grape. There is one case study with our scanner, but I unfortunately forgot to add that. When you asked me, I just remembered that. I'll just go through that, sir, and definitely I'll make sure to make it available to you how it is and how it has been utilized in that application.
Yes.
Okay. Thank you, sir. Then let's connect everyone by another 5 minutes. Sir. Thank you.